Hey guys, this is Joe East here. Today we're going to talk about battery systems. I was in this business for about 14 years and mainly focused on lithium battery systems. So that's my background. Some of this would apply somewhat to other chemistries, sometimes not, but perhaps 90% can apply to other chemistries. So let's jump in here really quick while we're not waiting. So let's start with the basics of batteries, where just about every battery has to have these characteristics. And sometimes battery manufacturers or battery engineers or people involved in the batteries manufacturing or engineering might use slightly different terms, and I'm going to point these out to you. So batteries are going to have three things you need to know about after they're manufactured and after they're installed and after they're tested. Typically, batteries are going to be periodically tested if they're in critical systems or not expensive systems. So capacity is the amount of energy the battery has at any given time. So there's rated capacity and there's actual capacity, right? So the manufacturer's rated capacity versus perhaps after it's tested after a few years, it might be different. But capacity is usually measured with two different units, depending on how you're using it. More engineering systems guys are going to use one term, and if you're more applications service guy, you're going to use another term. So if you're application and service into the business, you're going to probably get your capacity in amp hours. And let's just say, for example, we have a battery with 100 amp hours to keep the numbers round in this particular example. All right, we're back here. So if you have a battery with a capacity at 100 amp hours, that means that if you have it at full capacity and you discharge it at 100 amps, in 1 hour, the battery will be drained down to zero. Nothing left in it. Okay, one more time, let's go over that. If your battery with 100 amp hours of capacity is drained at 100 amps within 1 hour, this battery will have zero capacity. All right, 100 amp hours. It kind of makes sense. 100 amps in an hour, and that's its capacity. All right. So what happens if we're more of a systemic engineering type and we want to go toward real energy units of watt hours? Okay, you could also do it in joules, but watt hours is easier. So what you need to do to convert to watt hours is you're going to need the nominal voltage of the cell or the stack. Okay, so let's just quickly look at the power equation, and then we're going to show you how the conversion goes from amp hours to watt hours quite easily. So your power equation, and this is a side note, P equals VI. We've all learned in high school physics, perhaps. So if we have, let's just take a battery cell of typical lead acid, 2 volts, 2 volts per cell nominal. Let's just do it that way, right? So we're going to say 2 volts per cell nominal, all right? So in these two numbers here to convert to watt hours, all right, we already have amp hours, so we already took care of hours, okay, the time. What we need to get to is P for watt hours. So we need to make sure the equation is plugged into the VI to give us watts and the air in the watt hours equation for calculation of energy, right? Okay, so how do we get there? Okay, so we have amps here and a piece of it, and we have volts. We already have hours, so we have to deal with hours. So let's just multiply amps times volts. Amps here times volts. All right. So 100 amp hours. We already have hours, right? Right here. Volts 2. All right. 2 times 100 is 200. Okay. 200 watt hours. Okay. That's a quick and dirty calculation. There's an issue with nominal voltages on batteries. We'll get to that in a later lecture. But just for purposes of introduction, multiply your nominal voltage of your cell times the capacity of your cell. Do not get into the complications of series and parallel at this point. That's more of an expert level calculation that you're going to need to go through some more lectures to understand how that works out. But for just a single cell at 100 amp hours at 2 volts, your watt hours is going to be 200 watt hours. Just plugging in the straightforward equations we all learned in high school physics. Okay, so state of charge. Let's go to the next topic. So we cover capacity. It's either amp hours or watt hours. It's a measure of energy, of how much energy the battery is capable of holding. And there's different levels. There's rated versus actuals, right? So rated is what its nominal come out the factory, 100 amp hours rated by the factory. And there's the testing of it. It could be below 100 or above 100, depending on how the test comes out and depending on the type of cell you're going to be testing. And we'll get into that. So state of charge. Let's go to the next topic. State of charge is very similar to a gas tank concept. So if my gas tank is full, we're going to call that 100% full. All right, full. If my gas tank is empty, we're going to just say that gas tank is 0%, right? That's all state of charge is how much gas, electrons are in this tank, all right? This is an electron tank, is a battery, right? So how much charge is in there that I can pour out, okay, as it were, all right? So you don't want to have a state of charge greater than 100% or below 0%. That's typically not accounted for in systems engineering of batteries because state of charge is how much this battery can contain at one time as a ratio of how much it actually has at this point in time, state of charge. So if a battery is fully charged, you can say it's 100% state of charge. If a battery is completely discharged, you say it's 0%. Again, we're going to dive into some of the specifics in later lectures, but that's basically the gas tank concept of what state of charge is. So nothing above 100, nothing below 0. It just swings between 0 and 100 or 0 and 1, depending on what sort of mathematics you want to use. All right, so state of health. All right. State of health is how much gasoline, how big the tank is, right? Okay, let's see if I can say that in a better way. The size of the tank. So as a battery ages, the size of the tank, the electron tank, is going to shrink, as opposed to, say, gasoline engine, which they don't shrink, right? So that's why we have to have state of health, because the gas tank or the electron tank in the batteries is going to shrink. All right, that's why we have state of health. So state of health is the percentage size of the gas tank or the electron tank, as it were, as a ratio of the manufactured capacity. Okay, so let's say the manufactured capacity is 100 amp hours, and I test it, and it's 110 amp hours at a certain amount of time. Let's say 3 years later, I test it, and it's at 75 amp hours, okay? Okay. This is test 1, test 2. Well, it's very straightforward what the state of health is because I'm using round numbers. So the state of health here is 110%. State of health here is 75%. Okay. That's why I put in here state of health can range from 0 to 100%, but you can go above 100% because sometimes it comes off the assembly line from the manufacturer with more capacity than the rated. And that's possible. I think mainly in lead acid is very common. Other types of chemistries also. If it's less than capacity, I would say it's going to be 75%. So this is the nominal size of the gas tank, as the manufacturer says it should be rated, okay? And then if its actual measurement is above then the state of health is above 100%. And if the actual capacity measurement is below the rated capacity, then it's obviously below 100%. In this case, 75%. Okay, got that? So state of health accounts for the shrinking gas tank phenomenon of battery systems. All right. So as a battery ages, as I said before, the gas tank or the electron tank capacity is going to shrink. We don't see that in gasoline engines. So what does, if we have a difference in capacity actual versus capacity, say, manufacturer's nominal, then what we have, right? Let's say when we're getting in the state of health, so that's the next issue. So we cover capacity, state of charge. Let's go on the state of health. So let's say we have a nominal capacity of a battery of 100 amp hours. But we measure, let's say this is rated. All right. And we measure, say, 75 amp hours. All right. We perform a test, and it's only 75 amp hours. That means the state of health of this battery is 75%. Okay, very simple. It's just a ratio of actual measured capacity versus rated capacity. Now, some systems engineers might have different definitions, but this is the most common one I ran into while I was doing this for 14 years. It's probably the easiest to understand, and it's straightforward. Now, I put a plus after 100% state of health. Now, what does that mean? Okay, so let's say we have a battery rated at 100 amp hours, and we test it, and we have 110 amp hours in the test. All right, so this measurement is measurement A. Let's say measurement B is, see, 175, let's go, what we say, 110 amp hours. And this is possible, by the way. Those of you who are not familiar with batteries, this is definitely possible to have a rated capacity of 100 amp hours and measure it, and it'd be 110 amp hours. So in that case, the state of health is 110%. Okay, so that's why you can have greater than 100% state of health, and we can't have greater than 100% state of charge, because state of charge is how much gasoline I have in the tank. State of health is how big the tank is. Okay, so as a battery ages, the analogy could be, if you want, you have a gas tank for electrons, and as the battery ages, the gas tank shrinks. All right, that's what state of health is. All right, but as your gas tank shrinks, you still have a full or empty there, which swings between 100% and 0%, even though the gas tank is shrinking. It's just a percentage of the gas tank at its particular size. So state of health tells us the gas tank size as it shrinks as the battery gets old. State of charge is the percentage of gasoline, as it were, or electrons within the tank, no matter what the size of the tank is. So that's another way of thinking about the difference between state of charge versus state of health, and relating that all to capacity. Okay, this is the overall systemic stuff you have to know, very basic stuff for battery systems. So I hope you've enjoyed this. If you guys got any questions, like I said, I did this for 14 years as a systems engineer, so I got plenty of stuff to share with you guys. If you want to go a little bit deeper, just contact me, and we'll go from there. We'll see how we can help you. Again, this is Joe East. You guys take care. Stay safe out there. Goodbye. Thanks a lot. Take care.